I want to simulate the type of random walk where I tell it how many steps to take. So remember how this works. We started at 0, and then we kept adding randomly either 1 or -1 for a fixed number of steps. This is what I called the for loop random walk back when we were doing MATLAB. So as an example, we're going to use nestlist to make this. For the second type, for the while loop type of random walk, we're going to use nest while list, but for this one we use nestlist. And how many times do I want to add +1 or -1? Let's say 20 for now. And I want to start at 0. And the harder part is, how do I get the function? What should the function be? Well, the function is supposed to be add 1 or -1, where you randomly choose between them. So there are a few different ways to do this. Let me do it with a pure function. So pound is my variable, and then I want to add randomly either 1 or -1. So let me define that separately. Let me say step colon equals random choice 1 or -1. So remember what that does is each time I evaluate step, it's going to randomly choose either 1 or -1. So what's my function? My function is add step. Add either a random choice of 1 or -1. And there we go. If you look at any specific point in this list, I get to the next one by either adding 1 or -1. So in this case, I added 1. For this case, getting from -8 to -9, I added -1. And then lots of times what we're going to care about is what's the final value of this. So for example, maybe I want to do this 1,000 times, okay, always with step size of 20, or always with 20 repetitions, and I want to know what's the average final output. So let's try that. So let's make a table with this in it. And let's do it 1,000 times. And if all I care about is the last entry, then I don't really need nestlist. I could just use list. So there we go. These are the possible outputs. And if I want to know what's the average of this, I can do mean. And if I want to see a numeric approximation for it, I can put it inside this n. Okay, and let's try it with more repetitions. Let's try with 10,000 of these. Okay, how about 100,000? So it's really close to 0, and that makes sense because it's just as likely to be positive as to be negative. So there's this symmetry that's balancing out and giving us an average of very close to 0. If I want to get a more indicative average, maybe it's more interesting to put the nest inside an absolute value, brackets. And here for average in terms of absolute value, it's 3.5. So one way to think about that is, on average, we're 3.5 units away if we do this random walk with 20 steps.